So the next problem is that we have what we call, we are given u in 0 now, and we would like to find u in 1, given the same matrix, of course, same rotation matrix that relates the green frame with the red frame, okay? So again, we start with what we know. So u0 is equal to, u in 0 is equal to r1 to 0 into u in 1, okay? But we would like to know actually u in 1, not u in 0. So what do? We multiply both sides, we pre-multiply both sides by the inverse of this matrix, okay, which is the rotation matrix. So I multiply this side by r1 to 0 inverse, and then this is the remaining part of the left-hand side, okay, is equal to what? R1 to 0 inverse into R1 to 0, okay, into U in 1, okay, and you know that these two matrices are the inverse of each other, so they cancel, and you're left with identity matrix, and identity matrix times any vector equals the same vector because it's the multiplicative identity, okay? So we know that the right-hand side will be equal to u1. So I'm going to now switch the sides of the equation because we want u1. So let's put u1, u in 1, okay, in the left-hand side, and then we are left with this quantity in the right-hand side, okay? But hold on a second. What is the inverse of a matrix? By orthogonality of matrices, okay, of rotation matrices, okay, we know that the inverse is nothing but the transpose of the matrix, okay? It's the same as the transpose. So we can replace the inverse by the transpose. So we have this matrix here, okay. Copy and then paste here, multiplied by, but we have to transpose it first, okay? And this is multiplied by what? By 0 and 1, which is u in 0, okay? And then, so what is the transpose now? Basically, you switch the rows to columns and columns to rows. So let me see what I can do here. So let me highlight this row here, okay? And then it becomes my first column. So this is the first row. In the transpose version, it becomes my first column. So let me write it down here. So 1 over, let me take also, you know what, let me just do it without taking out the root 2. Okay, so 1 over root 2. And then the second row is going to be 1 over root 2. So this has been transformed into a column. This row has been transformed into a column. And this row, the second row, is going to be the second column. Okay, so let me just write that down here. So minus 1 over root 2, and then 1 over root 2 into 0 and 1. And you can see that I can take out the 1 over root 2 to simplify my calculations. So 1 over root 2 into 1, 1, minus 1, 1, and then I have a 0 and 1. And then this is going to be equal to, well, what is the dimensionality of the product of these of this matrix by this vector? We expect that 2 by 1 vector. Okay, again, because the left-hand side is a 2 by 1 vector. Okay, so 1 over root 2 into 1 into 0, and then plus negative 1 into 1. And then the second row is going to be 1 into 0 plus 1 into 1. And this is equal to 1 over root 2. Okay, and the first one is a negative 1, and the second one is going to be a 1. Okay, so this is the representation of u in 1. Okay, in frame 1, given that the representation of u in 0 is 0, 1. So let's see whether this makes sense or not. So we have u in 0, which is 0, 1, which is this, basically this. Let me use a highlighter here. This vector here, 0 and 1. Okay. So what is the representation of this in frame 1, which is the green frame? Okay, we expect something root 1 over root 2. Okay, something that involves 1 over root 2, and this is actually the case here. We have minus 1 over root 2 minus for the x-axis, because basically in the x-axis goes this way. Okay, it goes this way for this frame, but here we are going the other way around. Okay, other way around into so where is our vector now? So it goes this way. Okay, so if you basically extend this, okay, our vector is going to be this. So it goes this much opposite to the x1 direction, and then this much into in the same y1 direction. Okay, what is this? Basically, it's 1 over root 2, or negative 1 over root 2. This one is negative 1 over root 2, and this one is 1 over root 2. I hope this example is clear. Okay. Let me stop here and continue to the next video.